Okay, so we've been exploring these conditional structures. We looked at a simple if, and then we looked at the if then else. And now we're going to look at a special kind of if where they're sort of chained together. So this is called the cascaded if structure. So before we go, let's look back again at our if then else structure. So you can see again here that we have two code blocks and we're going to run one or the other. So see how that's sort of an exclusive set? I have code block A and B. If the condition is true, I run A. If it's not, I run B. So mathematically, we show in notation a set like this. Now, don't worry about that. We don't have to get upset about any formalism or anything here. It's just useful to show this. So this is an exclusive set. And when I say an exclusive set, I mean a set where we have multiple options and only one is true. That's really important, okay, for us to use this structure. We have to use it properly. So there has to be when we have several cases, maybe two, maybe five or six, where only one can be true, okay? And then we'll pick the one from the set that's true. So we just saw that this gives me two blocks, which I can call A or B. If the condition's true, then I do A. If it's not, then I do B. So either way, I'm going to pick one of those two conditions. All right? Now, let's consider where we have more than two options. So if we have an exclusive set of three items, A, B, and C, we can look at this, and again, the deal here is that one has to be true. So if A is not true and B is not true, then we don't have to test for C. We know that C is true, and we don't have to test because we've excluded the other members of the set. There's only one left. The rule is that one has to be true. Okay? So we can say this another way. If we have an exclusive set where only one element can be true, and we eliminate all of the elements except for a single remaining one, then that remaining one has to be true, and we don't have to test to see if it's true. So now let's look at the pseudocode here. Now this is a really important slide because this is very easy to get confused about logic, so you want to look at it carefully. So here on the left, I have the new logic. And so the basic idea here is if A is true, we output it's A. If B is true, we output it's B. Otherwise, if it's not A and it's not B, we output it's C. And notice I don't have any test condition here because I've excluded A and B, so then it has to be C. And notice how that works. I have to do exactly one less test than I have in the group. Now also consider this. If we find that A is true, we don't test for B or C. You see that? So basically we only test as many times as we need to. Now let's look over here. Here we have really three separate tests that are not connected. So if A is true, we output it's A. Even though we already know it's A, then we go on to see if it's B, and of course it won't be, and then we see if it's C, and of course it won't be. So you see how that's wasteful? So when we have an exclusive set, we want to use the cascaded structure, so we use the minimum number of tests to determine which of the cases we want. This is a very inefficient structure because you can see that it's always going to do more tests than are needed, whereas this test will do the minimal number of tests needed. Now that's only for the case where they're exclusive. If A, B, and C aren't exclusive, then we have to test for them separately anyway, and we have to do this. And that's the case where A and B and C could all be true or some combination. When they're exclusive, only one from the set can be true. Okay? All right, let's go ahead and write another example logic program. And we're going to sort of arbitrarily say that you have to choose a color. and it has to be red, blue, or green, and you can't choose any other color. So we have an exclusive set of 3 options. Once we've eliminated 2 of the options, we'll know that you picked the 3. Okay, let me go ahead and get into my Word document where I've, whoops, I wonder if that'll let me shift back. Yep, good. So I've set up my program here, and this is for the Programming Logic and Methods section, Demo 5, the Cascaded If. So I have sort of a title here and a little description of what it did, and this is in a comment block. Okay, so let's go ahead and find a good name for this program. And let's call this Cascaded Color Choice. Okay. Now I don't have any of the code written yet here except for this outline, and of course all the code goes in here. And so what I'm going to do is I have to set my variables, and really I only have one variable here, and this is going to be a string, and this is going to be color choice, and then I'll put a little comment here that says that this will be red or blue or green. Okay, and we'll go from there with that. Okay, so for my input phase, I'm going to ask the user what color do you choose, or I can just say choose your color. So let's do that as a prompt. Output, choose your color, and then notice how I'm going to do this: red, green, and let's do it a little differently. So we'll prompt them, choose your color, colon, red, green, or blue, and then I'm going to use the parentheses to show that all they have to really give me is the first character. So red, green, or blue, like that. Whoops, let me put a separator in there. I'm having a little bit of trouble typing. This is the last video of the day. It's about my 5th one, and I'm getting tired. Okay, so choose your color, red, green, or blue, RGB. All right, of course, now we're going to do the input, and this will be a string type, and that'll be color choice. So the user is going to tap the R, G, or B key, right? Input color choice. All right, now we'll start the selection structure with the cascaded if to see what they choose. So if color choice. Now I'm going to introduce something here because usually we use this for assignment where we set something to be a value, and when we test, really we should use this symbol instead, a double equal sign, and that means is it. So if color choice is equal to R, which is red, and this should be a string because that's a string, right? So it's a string variable. It'd be okay in the pseudocode to not put the quotes in there, but it's smart to do that, okay? Because when you go to Java, you'll have to quote string literals like that. So basically, we're comparing a string variable to a string R, and we're seeing if they're equal. And then you'll see in a moment we'll do the same thing here with the B. So if color choice equals R, if that's true, then output you chose, whoops, red. Okay. And then now this is where we do the chain. So we have an else, and then immediately we have an if, and again we'll continue with color choice. So if color choice equals, that is if it's equal to green or G, then output you chose green. Okay. All right. Let me fix my lines here. I keep forgetting to tap the Control key here when I hit enter, and then Word puts in a full line. I don't want that. I want these lines a little close together. There we go. Okay. All right. And now you would think that I'd say, okay, else if color choice equals blue, right? But that's kind of silly. I don't need to test that. So the else clause is I know it's blue. I know it is blue. I'll put that in a comment. So then I'm just going to go ahead and output you chose blue. Okay. And then we have to have an end to the structure here. And this is just going to be end if. So notice now I have this whole structure which begins with the if and ends with the end if, and then I have the else if, like that. Okay? All right. So that's how we do that in the pseudocode. And basically it's called a cascade. And you can see that it just continues on. Now I can do this with any number of elements. So I can create a set of 6 exclusive objects, test 5, and know that I got the 6th one, or exit out early when I found that I have one of the previous ones. It turns out later on we'll see that in Java and many languages we have a different structure we can use when we have a whole bunch of these. So usually we don't go past maybe 3 or 4 like this, and then we use the other selection structure. In some languages that uses a keyword called select, which is what we have in Java. And then in JavaScript and several other languages, instead of select, we have switch. Okay, so again, it's really important to understand the difference between having this cascaded 3 connected choices as opposed to having 3 separate if choices with the simple if. They don't mean the same thing. When you have this condition like I had in the slides here, where is that? Sorry. Like this on the right, where you have the 3 possibilities, that kind of implies that you can have 2 true at the same time. So this tests them independently. So again, A and B and C could be true or false, right? So this assumes that we have an exclusive set where only one of the 3 can be true. And so it's very important when you're doing a program to figure out which one of those sets you need. Okay? All right. I hope these videos are helpful for you. Obviously, I'm going to go over this in class too, but you know, I think sometimes the videos are really